Alright, ladies and gentlemen, just a quick video of how to predict the products of chemical reactions. There's actually something that's a little bit more complex than this we'll learn about when we get to solutions. But the basic way to predict products of chemical reactions is step 1, figure out what type of reaction it is. Now these are mostly single and double. Anything else I've starred, okay, and you can always check the answers in the back. But this one I see a single element and an ionic compound, a single and a pair. So single and ionic, it's going to be single replacement. So the like terms, so in this case the metal will replace the metal. And so I want to switch the Ag and the Cu, switch their places. Now step 2, when you're predicting the products, so I'll have the Ag with the SO4 and then the Cu by itself. You don't carry over the subscripts unless they belong to a polyatomic ion. Like this SO4 right here, right? That is a polyatomic ion. So SO4 carries over. So we have Ag, SO4, and copper. Step 3 is to check chemical formulas. This is like a super important step. If you don't do this, step 4, which is to balance, won't work out. This is not working out. It's harder than this. So we have a silver and a we need to check our chemical formula. So silver is a +1 charge. I look at my polyatomic ion sheet. Yes, you need that polyatomic ion sheet. That's a -2, a +1 and a -2. This is Ag2SO4 to balance our charges. And then Cu is just fine. So now we balanced our we checked our chemical formulas and fixed them. Now we can balance. We have 2 Ags on this side. We'll need 2 Ags on this side. And then we have a Cu and a Cu and an SO4, SO4. Awesome. Great job. So I'll do one more with you. And we'll work on these in our lab tomorrow as well. So I see a pair, an ionic compound, and an ionic compound, a pair and a pair. So that's double replacement. And so the metals will switch. So I predict my products. So I have Na will switch places with the Ca. So I'll have Na and Cl. Now this little 2, it's not a polyatomic ion, so it doesn't carry over. So it's just Na, and I'll carry over the Cl, and calcium, and the iodine. Okay. Now I need to check my chemical formula, so I need to check the charges. So Na is a +1, this is a -1. Oh, we're good. But calcium's a +2, and iodine's a -1. So we'll need CaI2. That's the correct chemical formula for that compound. And so now I can do step 4, balance it, Na, Na, IO. I'll need 2 of these I's. Then I have a Ca to Ca, 2 Cl's, so I need 2 NaCl. That balances. Okay, and you keep going. Now notice that the next one is starred. Okay, so it's starred, so it's not a single or double replacement. And so I see H and O. Oh, what does that make? It makes water. Now to make your life easier, you can rewrite water HOH. Okay, you can balance it, or you can write it H2O, because that's a synthesis. There's not too many of these. Mostly they're single and double replacement. So here we say, okay, HOH, there's 2 H's and 2 H's, that's happy, but there's 2 O's and only 1 O here, because we know the formula of water, so I didn't check that. So we need 2 O's, and now we've got 4 H's, so we'll need 2 H's. This balancing is wrong in the answer key, but this is correct, I promise you. The next one is we have a pair and a pair, and that is a double replacement. Okay, so you see a pair and a pair. In this case, there's only one metal, so you're like, who's going to switch with you, metal? It's the hydrogen, because the hydrogen ion acts like a metal. It's positive, and so positive switches with positive. And so we'll get H, and then the OH. This 2 is not part of the polyatomic ion. It's just saying you have 2 of those OHs. So we'll get H and an OH. Oh, look, that's water. And then the Mn and the NO. In this case, this 3 belongs to that polyatomic ion. We're going to chunk it and keep it together. So I'll carry that 3 over. Okay? So only if it belongs to a polyatomic ion do we carry it over. Then we check our formulas. +1, -1, that's good. Mn is a little tricky. It's a +2. I know that because here, OH is a -1, so that means Mn had to be a +2. I had to get that from over here. Mn's a +2. NO3 from my polyatomic ion chart is a -1, so we're going to need 2 NO3s. Okay, so we're going to need to come over and balance them. 2 NO3s. We need 2 OHs, so we'll put that here. And look, 2, 2, and we're balanced. Okay, we'll work on it together again tomorrow. This is just a little video to help you out. All right, see you soon.